Alrighty guys, so now we're going to talk about the pathways themselves. So I just kind of split these videos up so you could just jump to whatever parts that you want to listen to. So we labeled this the direct pathway, and then we'll talk about the indirect pathway next. And something I try to keep in mind with basal ganglia is I like to start with my end game. So I know that direct pathway equals movement. And because I know that, it'll kind of make things a lot easier. So we have two major neurotransmitters involved, right? We have GABA and glutamate, right? So I'm going to keep a little note down here that green is going to be glutamate. Okay, and we'll keep that nice and open there. And then we've got red is going to be GABA. So just so that we can keep that all in mind, right, as we're drawing this out. So for direct, we want movement. And something, there's just like a few rules that you could just keep in your head. So I know that the striatum is going to be my starting point for the basal ganglia. So even though the cortex is of course going to tell the striatum like what to do and that we want to initiate movement, this isn't like our starting point. Our starting point is going to be the striatum, and then when we incorporate dopamine, we'll talk about that. So that would be our substantia nigra pars compacta. So cortex and some sort of excitatory stimuli, but now that we're in the striatum, we can initiate basal ganglia. And we know that basal ganglia is just like a modifier of movement, right? So we know that it stimulates and inhibits movement, and it is almost kind of like the cerebellum where it's a little bit regulatory, right? So it's just going to make our movements more smooth and things like that, so fine movement. So the striatum is always inhibitory, always, always. So I want to just emphasize that because it's always going to release GABA. It does not release glutamate. So whether it's part of the direct pathway or indirect pathway, and now see I'm making this giant red line because we're flooding our globus pallidus interna with GABA. So a huge amount of GABA flowing through. So the GPI is also always inhibitory, right? So this is going to want to release GABA, but because we're inhibiting something that is releasing GABA, we are going to only have a tiny little bit released, right? So it's always going to release some, but you know, it's a small amount. So we're inhibiting the inhibitor there, right? So because not much GABA is released from the globus pallidus. So globus pallidus interna does not want movement, but because we sent out so much GABA from the striatum, we inhibited GPI and now release just a tiny bit of GABA. So we do this thing called disinhibiting the thalamus, right? So we disinhibit the thalamus, which allows the thalamus to go ahead and stimulate the cortex, right? And say, okay, we want movement, now we can stimulate spinal cord, and we have a ton of movement there, right? So because we have lots of movement, well, we can use a bigger line there, right? So we stimulate, and we go ahead and do that, right? So that's how we have movement. So in simple words, disinhibition of the thalamus causes movement there, right? Okay, cool. So we have that, and now we're going to go ahead and talk about the the indirect pathway. So I just want to make sure I didn't miss anything. So yeah, you can call these like two different pathways. I guess I kind of drew them on top of each other, but we would just do this, and then we would say the cortex then sends a stimulatory to spinal cord. Okay, cool. So now let's talk about indirect. So I'm gonna move this, copy that, and we'll move over here to our blank template, but we'll keep this down here to keep it in mind of our neurotransmitters. So up here, I'm going to write indirect so that I could always remember what I'm doing equals no movement. And I know many of you are probably you're watching this video, you kind of already have the gist of this. This is going to become really important in pathology, so I just want to use terms that could possibly be used on your exams and things like that. So I know that the striatum is going to be my major initiator, right? And I know the striatum is always inhibitory. So I release a ton of GABA, right? So I inhibit the globus pallidus externa. And like I said before, my GPEs are also normally, well, they're always inhibitory. So I send out a little bit of GABA to the thalamus. So now, sorry, if I said thalamus, I meant subthalamus. So my subthalamus is now disinhibited. So my subthalamus is actually really stimulatory to my globus pallidus interna. And like I said before, my globus pallidus interna is very anti-movement, lots of GABA, which means that we're going to have barely any response from the thalamus. So the thalamus can't really tell the cortex to move, cortex can't really tell spinal cord, so that's why those lines are so much thinner. So they're still releasing those neurotransmitters, right? So GPI is releasing GABA, striatum still releasing GABA, all of those things. Thalamus, low movement, right, because we were very inhibited. So they really like the term disinhibition. So in our direct scenario, the thalamus was disinhibited, right, because we dropped the GABA there, and then here our subthalamus was disinhibited because we dropped the GABA in our globus pallidus externa. So this is as simple as I can make it. Two major questions that can be asked, right, are is the striatum like excitatory, inhibitory? And we know it's always inhibitory regardless of if it's direct or indirect, and it's always going to release GABA. And same with our globus pallidus, both interna and external. They're two like inhibitory structures. They're going to release GABA, and it just kind of depends on what other structures are involved. So because this was just like a little overview, I'm going to stop the video here and then go ahead and do another video on pathologies. So the next thing we'll talk about is Parkinson's.